Solving polynomial equations. Zero factor property. If the product of two numbers is zero, then at least one of the numbers must be zero. If a and b are real numbers and a times b equals zero, then either a equals zero or b equals zero. So this is their zero factor property. Assuming that one of your multiples is going to be zero, causing it to become a zero as a final result. So let's try out an example. So, solving by factoring. 1. Write an equation so the one side of a is equal to 0. 2. Factor the non-zero side of the equation. 3. Apply the zero factor property. And 4. Solve each equation that results from using the zero factor property. As an example, we have in this case, negative x squared minus 4x minus 1 equals 3. Notice it's written just as you would enter into a computer, okay? Be aware, that way you get used to see it in both formats. But otherwise, let's notice that does it look like ax squared plus bx plus c form equals 0? And we typically have to set it equal to 0 if it has an equal sign. Let's first realize if our a value is 1, then we can use the simple method of factoring. Simple method, we find the multiples that give us the c value, and added should give us the v value in this case. So let's try it out. We have negative x squared minus 4x minus 1 equals 3. And it does not look like it's set equal to 0, so we must set it equal to 0. So let's get rid of the 3 to the left side. So minus 3 from both sides to set it equal to 0. There we go. Negative 1 minus 3 gives us negative 4. So we have negative x squared minus 4x minus 4 equals 0. Okay, so it looks like all three terms have a negative sign. Wow. If we keep it with a negative, that's going to make it a little more complex, because a would not be equal to 1. A would be equal to negative 1, and then we'd have to find a multiple. So in this case, how about if we try factor out the negative 1 then, or a negative from all three terms? Once we factor out a negative 1, as we've done in this case, we can divide it out. So let's divide about negative 1, and since the other side is equal to 0, divided by negative 1, 0 divided by negative 1 is 0, agreed? Negative 1 divided by negative 1 on the left side cancels out or gives us just a positive 1 or just a 1. So there it is, our simplified form, x squared plus 4x plus 4 equals 0. And now we can factor in this case. So let's find the multiples that give us the 4. And in this case, keep in mind it's the c, it's the one that has no x, but it would make a difference since in this case both of them are 4s. When added, we should get the 4. This is the one that has the x, single exponent, no, not the square. But let's try them out. Multiples that give us 4. 1 times 4 and 2 times 2 gives us 4. Notice they're both positives, agreed? So the signs do count. So both of them should give us positive 4, which they do. And now we add them. 1 plus 4 gives us 5. That won't work. It doesn't give us 4. 2 plus 2 gives us 4. Hey, that works. So the 1 plus 4 doesn't work, but the 2 plus 2 does work. It works both for the multiplication and addition. So in that case, though, that is our right combination to choose. So putting our parentheses, we have 2 sets of parentheses with an x at the beginning of each. And putting in the positive 2, since they're both positive, the order doesn't make a difference, right? Either way, we know that they're both positive. So we already found our right sign on them. So there it is, we factor them. Now it remains to use the zero factor property. Zero factor property in this case implies that you're setting each one of those parentheses equal to 0. So separate them. Separate both of them out and set them equal to 0. So x plus 2 equals 0. And in this case, it happens to be repeated. But if it wasn't, you technically do the same. Hence the reason why I'm showing basically separation of both. But we're going to end up with the same answer at the end. But I'll still go through the steps that way you can see them in case they weren't the same for you. So separating it out and solving for x. Let's get rid of the 2 from both sides. There we go. And let's give our final solution as x equals negative 2. And you will repeat it for the other one. In this case, once again, we're getting the same answer. So, subtracting from both sides of the equal sign there. And that will give us that x equals also negative 2 in this case. And finally, I'm just going to state as a final result, x equals negative 2. We have a single answer. It couldn't hurt to double check or do a quick check on our calculator, right? So I highly recommend you try it out. turn on your calculator. And I already have my calculator out. And let me go back to the beginning. So when your calculator's on, you should get something similar to this probably. We want to go to y equals, very top button where it says y equals. There we go. And in this case, we're just plotting the equation, right? Well, I'm plotting two equations. I'm plotting the original ones. So negative sign from the very bottom, right next to your enter button, you have a negative sign, push down, and it's negative x. There's a square. You can either use the caret key right below the clear button, or on the left side, somewhere towards the middle of your keyboards there, you'll find an x squared. Whoop, missed the x. There we go, x, and then you can push the squared. Otherwise, if you use the caret key, it'll look like this. Negative x to the power of 2. If you have a TI-84, you push forward in order to bring it down. TI-83s, you can keep going. So now minus 4x minus 1. There's your first equation. The left side of the equal sign, which we see in the example there on the left side. I'll hit enter, and I'm going to graph just the 3, the right side of the equation. So now go to zoom, and I'll do a zoom standard, option number 6, and let's see if we can see where it graphs, or intersects, I should say. There it is. It looks like it intersects there. I'm going to go for the zoom feature to make it easier to see. Zoom. And I want to do a zoom box. So middle top button is your zoom. We want to do zoom box, option number 1, push number 1, or hit enter on number 1. And I want to find my cursor. There's my cursor. And I want to graph part of my y-axis, so I'll go a little bit down lower. Yep, right there's my cursor. I'll hit enter once and move up. I'll push the up button and it'll move up continuously. There we go, probably a little too high. And go back down, and I'll go to the left now so I can show a box. And it's going to zoom into that area where my box is. So I'll hit enter, and now it zooms into that area. So there's the parabola, and there's a straight line where y equals 3, or of 3. And it looks like it may just barely nick it, right? So it's a single location. We can actually have the calculator do a little bit of work for us. Push the second button, and push the trace button up at the top right. Second button from the right. It gives you the option of calculate. We want to find the intersect. Option number 5. Push the number 5 button, and it automatically goes. It asks you, which one's your first curve? Hit enter. Notice at the top, mine says y1. When I hit enter, it should switch to number 2. There it goes. It did. It switched to number 2. It says y2 at the top now. Yours should do the same. Hit enter again, because that is the second curve. I'm telling you yes by hitting enter. It gives you a guess. You don't want to guess. Hit enter again so it can give you the exact value. And it's calculating it for you. There we go. It calculates the intersection at x equals negative 1.99999, and the y value is 3. In this case, we're looking for the x value. Let's see behind our calculator. The y value, not critical in this case because we were looking for the x value, right? The x value is negative 2. We got negative 1.999, which is pretty much negative 2. So there it is. We verified with our calculator that it actually works. We calculated the intersection point. And we also got a chance to see where the intersection point is. It intersects once, hence the reason why we only got one solution. I'll zoom out once again, and I do a zoom standard, option 6. Now we can see all of it once again. There it is. It intersects at a single location. So now that we verified with our calculator, we can see that our answer is correct.